Hi, welcome back. This is Professor Ridge, and today's lesson is on section 2.6, the algebra of functions. Alright, so starting off, basically we're going to define what does it mean to add two functions, subtract two functions, multiply two functions, and divide two functions. And basically what I always tell my students is you're going to apply this definition. If you're ever asked to add two functions, simply you're going to find the y value for f at that x, given x, find the y value for g, and then you're going to add the two y values together. So basically the way you add two functions is you just add, for each x, you just add their respective y values, and then that gives you the addition, the sum of those two functions. And you can do it with adding, subtracting, multiplying, and dividing. Now, we know we're not allowed to divide by 0, so this one we just have to put this little requirement, g of x cannot be equal to 0. Okay, so again, what does it mean to add two functions? Well, you just add their y values for each x. Alright, so let's look at an example. So we want to keep that in mind. So that's the definition of what it means to add, subtract, multiply, or divide two functions. So if I define f of x to be negative 2x plus 3 and g of x to be x squared minus 5, find the following. So this is from the book. Exercise, we'll start with number 8. Find f plus g of 4. Well, applying the definition for adding two functions, you're just going to go f of 4 plus g of 4. And then we know that this means we're going to plug in 4 for the x value in the f function. So f of 4 is equal to negative 2 times 4 plus 3. See, that's f of 4. Plus, now we're going to do g of 4. We're going to put in 4 for the x in the g function. That's g of 4. And we're going to work those two out and then add them together. So f of 4 is equal to negative 8 plus 3, which is negative 5, plus, and we're going to do g of 4, so 4 squared, that's 16, plus, minus 5, which is 11. And now add those together, negative 5 plus 11 is 6. So my answer is 6. So f of 4 plus g of 4, this is actually the way the book had it, but I want to emphasize the rule. Okay, so number 14, what's f divided by g of 3? So applying the rule, that's f of 3 divided by g of 3. Now plug 3 in for x in the f function, so negative 2 times 3 plus 3. Plug in 3 into the g function, 3 squared minus 5. Okay, work both those out. Order operations now. Negative 6 plus 3. Bottom is 9 minus 5. So we get negative 3 over 4. And that doesn't simplify, so there you go. Negative 3/4. Okay, so determinant domains of functions. So the domain of f plus g, f minus g, and f times g is the set of all values common domains of f and g. So for this graph that I drawn here, say this was the domain of f would be from -1 to 6, if that was 6. And the domain of g would be from 1 to, say that's 10. Then so basically the domain for f and g would be basically between 1 and 6. So that's the domain in common. So that's your domain for f plus g, f minus g, or f times g. Okay, so it's the where they have the overlap, if you want to think of it that way. All right, now the domain for f divided by g is the set of all values common to f and g, excluding any values where g of x equals 0, because if you divide by 0, that's undefined. And if you notice, g of x equals 0 right here, where x equals 3, so you would have to exclude from the domain x equals 3. So again, you're going to get the overlap. So it's going to be from 1 to 3, that would be an open circle. And then from 3 to 6, that would be a closed circle. So your domain would be from 1 to 3, and then from 3 to 6, and you would exclude 3 from the domain. Okay, so for each pair of functions f and g, determine the domain of the sum, difference, and product of the two functions. So we'll do number 42. Okay, so if f of x is 5x minus 1, well, remember our default is we're going to start out with all real numbers and look for anything that makes this undefined. And right now the two things that we're mainly looking for are zeros and denominators, which this is fine, and negatives under square roots. So basically the domain of f is a set of all real numbers, and same for g is a set of all real numbers, and then their overlap would be the whole real numbers. So domain of f plus g, f minus g, or f times g would just be the set of all real numbers. 44. So the domain of that one would be, again, there's nothing to throw out. There's no denominator. So that's going to be all real numbers. For g, 1 over x minus 9. Okay, now this we want to throw out. So what makes that equal to 0? So it's a set of all x's such that x is a real number and x cannot equal 9. Now the overlap of these two functions, these two domains, would be just the same as the domain for g. So the domain of, because this is all, the domain of g is all real numbers except that one spot where x equals 9. Domain of f is everything. So what do they share in common? Well, it'll be everything but x equals 9. So basically, we just see anything you throw out for f, you throw it out for the sum, difference, or the product, and anything you throw out for g. So anything you throw out for either one, you throw out for the sum, difference, or product. So x such that x is a real number and x cannot equal 9. So if f was had a fraction in the bottom, you wouldn't allow 3, then you would throw out 3 and you would throw out 9. Alright, let's try to find the domain of f divided by g. So for 52, f of x equals 2x cubed, g of x equals 5 minus x. Now our domain for f is a set of all real numbers. For g, it's also a set of all real numbers. But remember, the domain of f divided by g is going to be all real numbers, and anywhere where g, since g is the bottom one, anywhere that g is equal to 0. So now, when is g of x equal to 0? Well, that's when g of x is 5 minus x equals 0, so you solve that. So add x to both sides when x is 5. So you need to throw this one out, exclude from the domain of f divided by g. Now, see, it's no problem for g, but if g is the denominator of a fraction, then it's not allowed. You can't have 0 on the bottom of the fraction. So the domain of f divided by g is a set of all x's such that x is a real number and x cannot equal 5. All right. Okay, so looking at this graph, we got two functions, f and g. So if we do number 59, it says determine f plus g of 5. Or I can even just say evaluate. So we know that that's going to be equal to applying the definition, f of 5 plus g of 5. Now remember, this f of 5 is the y value when x equals 5. So I go to x equals 5, and I go to the f function, which is right here, and that is 1. Go back to 5 on the x, go up to the g function. The y value there is 3, so 1 plus 3 equals 4. Now 62, determine f divided by 3. F divided by g of 3, sorry. So by definition, that's f of 3 divided by g of 3, which is equal to, so f of 3, so x is 3, go up to the g function, or to the f function first, that's 2, go to the g function, so x is 3 is right here, the y value on the g curve is 1, so our answer is 2. Alright, what's the domain and the range? What's the domain of f, domain of g, domain of f is equal to the set of x's such that x is between 0 and 9. Okay, domain of g is the set of x's such that x is between Let's see, G. So remember, it's the x values from 3 to 10. That's the x values between 3 and 10. So the domain of f plus g is the overlap, so that's going to be from 3 to 9. So set of all x's such that x is between 3 and 9. And then f divided by g is going to be, now the thing we got to do is throw out anywhere that g is equal to 0, and it's not anywhere. So the domain of f divided by g is the same as f plus g. So it's x such that x is between 3 and 9. Now, if I asked you what's the domain, here, let me see if I can squeeze it up here. Domain of g divided by f, then that's going to be, the overlap is between 3 and 9. And then you got to throw out anywhere where f, since f is now on the bottom, anywhere where f is equal to 0, which is meaning where it crosses the x-axis. That's where the y value is 0. So we see here at 6, f is equal to 0. F of 6 is 0. The y value is 0. And at x equals 0, at 8, f is 0 too. So you got to throw out those two numbers where the f graph crosses the x-axis, because that's where the y value would be equal to 0. Okay, so it's going to be between 3 and 9, and you throw out 6 because f is 0 there, and if f is the denominator in this case, you're not allowed to divide by 0. So you got to throw that out. Alright, so that concludes our lesson for 2.6. Go to my math lab and complete the exercises there, and I will see you next time. And that concludes also the chapter, so make sure when you complete all the sections for chapter 2 at mymathlab.com, you're going to complete the chapter tests also. Alright, see you next time.